In this video, we're going to see how we can protect roots on our API using username and password. This is sometimes referred to as Basic Authentication or Basic Auth. And if you're using an API client like Postman, there's normally an authorization tab, and there's a whole load of different types of authorization. And one of those is Basic Auth. Basic Auth allows me to add the username and the password. So I'm going to use the username to be the email, and the password for now is going to be super secret. I'm going to send that request, and I haven't done anything with my API, so it's going to be successful. But more importantly, what I wanted to show is that the username mike@nike.com and password super secret gets sent using an authorization header. And the authorization header is in two pieces. It has basic, because it's basic auth, followed by a space. And then it has this string of characters here, which don't look like mike@nike.com and the password super secret. But in fact they are. They've been encoded using base 64. So on the back end, I will need to do a number of things. First of all, when we create the user, we're going to need to store the password in a safe way in our database. Secondly, when we receive a request, we're going to need to check that there's an authorization header, that it begins with basic, and that it has this other string. Next, with that string, we're going to need to decode it and separate out the username and password. We'll then check that our database has a user with that username. In our case, we're using email, so we'll find one using that email. And then we will compare the password that's been sent in with the password in the database. If everything's been successful, that user can access our protected root. Otherwise, we're going to return a 401 unauthorized header. That's quite a lot to do, so let's get stuck in. The first thing we'll do is we'll update our user model to have a password field. Currently, it has first name, last name, email, and role. We will add a password field. That's going to be of type string. It's going to be required. So when I create a user, I'm going to need to provide a password. So to create a new user, I need to post. I don't have any authorization set up, so I'll set this for no auth. And my body is set to raw and JSON. And I have this object, Michael Smith, last name Smith, first name Michael, project manager, and password 3. Let me send this. And I get back that whole object. The password is coming back in plain text. And if I get all of the users again on my get users route and scroll down, Michael's password is being stored in plain text. That is something we never want to do. Because if our database gets breached, if someone gets a copy of our database, they have the username and the password. Really bad, not just for our service, but also for our users. If they reuse passwords between services, we have opened them up to data breach security. Not good. So what we want to do is we want to hash our passwords. And the library we're going to use for that is called Bcrypt. So I'm going to install that. So I'll stop my server, and I'll npm install Bcrypt. And I'm going to go to my user model again. So Mongoose provides me the ability to hook into various stages of the life cycle of a model. Before it gets saved, as it gets retrieved, various other applications like that. So I'm going to use the user schema, and I'm going to say pre. And Mongoose wants to know which event do I want to invoke this function before, and I want to invoke this before the save function. I'm going to provide an asynchronous function which gets passed the next, which we'll invoke at the end to say move on to the next level of our Mongoose query. Inside of this function, I want to hash my password. In other words, I want to store a string in my database that represents my password. It's not the password itself, but it's an identifiable way to be able to find my password. So at the top of the file, I will import, so const bcrypt equals require bcrypt. I'll import bcrypt. And inside of this function, I'll do a try catch. In the catch block, I'm going to invoke next error, which will pass the error to the next level of middleware. In the try block, I'm going to test two things. I'm going to check if this, which refers to the instantiated version of the model that's about to be saved, is modified password. So I want to check, has the password been modified? Or is this new? Okay, so I only want to run this function if the password on this particular object has been modified or this is a new object. And in that case, I want to create a salt. Now, a salt is a random string that gets stored in our database alongside the password. It's another way to stop malicious users easily being able to find out the real plain text password for our user. So I'm going to await Bcrypt .generate salt 10. Now 10 represents the work factor, how many rounds of encryption we want to do in order to encrypt our password. A high number here will have a very secure password but will take longer to encrypt. A low number will be an easier to decrypt password but will be faster. It's exponentially bigger, so each time we increment it by 1, we double the work time or thereabouts. 10 is about right. It's about 60 milliseconds on my computer. Once I've got it, I'm going to update the current password to await bcrypt.hash. And I pass in the password and the salt. Now I'll start my server again, and I'm going to create a new user called James Anderson. I'll send this away, and I get back a password which doesn't look like the password 9 where we set the password. So this password field is the hashed password, but it also contains other information. So let me unpack it a little. $2b, that's the signal that we're using Bcrypt. It's the algorithm identifier. $10, that's the work effort or the salt rounds, that number 10 that we set. Then dollar and this longer string, and that is the salt and the encrypted password. That's what we store in our database. And if a malicious user gets access to our database, it will take them years and years and years to be able to get the plain text password from that string, at least with current computing methods. We now have the facility for our users to have passwords. What we want to do now is to ensure that our protected routes are only accessible when a correct username and password is passed in. So in the authorization, I'll set it to Basic Auth, and I will use James Anderson, our friend here. I'll take his email and put it in as a username, and I'll take his password. We haven't protected this route, so everything just passes through as normal. Let's see how we can protect the route. In my middleware's auth file, I have a function that checks the API key. I looked at that in the previous video, which I'll link to up here. So I'll change the name of this function to API key auth and export that as one of the types of auth we're going to have down here. So API key auth. And I'll create a new function, async function, basic auth. All of these middleware functions receive the request and the reply, and I'll export it at the bottom. Inside of this function, I'm just going to console log I was called, just to confirm it's being called so that when we do some work, we know what's happening. Now I'm going to go to my app.js. So at the top of my file, I'm going to import my basic auth from my auth library that I've created in the middlewares folder. And just before I start my function, I'm going to use fastify.addHook, which allows me to hook into various stages of the request response cycle. If you're using Express, this works just the same, but we do express.use, and that is going to be applied at the point that you are adding it to your file. Here, I want this function to run to just before my request response cycle gets to my handler. So I've done some of the validation, I've parsed the request, and I'm ready to invoke my handler function. But just before I do that, I want to invoke my basic auth function. It's called basic auth because it's username and password, but it doesn't feel very basic sometimes. So what I'm hoping is that when I invoke this function, is get all users, I'll get the users back again, but I'll also get this I was called in the platform here. Now there's lots of logging going on here, and that's going to get in the way of me showing something. So I'm going to go to the top of my app.js, and where I import Fastify, I've set the logger to be true. For the moment, I'm going to set that to be false just to tidy up my terminal so we can see what's going on here. So now we can explore this function. We know it's being called. So the first thing we want to do is to get that authorization header. So we say const auth header is going to be request.headers and it's authorization. And if there's not an auth header, we just want to immediately do our return reply.status 401 because it'll be unauthorized, and the message we'll send is error no authorization header. Let's try that. We have our authorization set here. If we send this, it seemed to work fine. If instead I set this to no auth and send, I'm getting no authorization header. Let's turn it back on again. So by this point, we know we have the header. Now we know that the header that's being sent is this string here. It's the word basic and then a space and then these characters. The word basic is verifying, hey, this is the type of authentication that's being sent. And this string is a base64 encoded version of the username and the password. So let's have a look. So I'm going to say auth type and auth key is going to be the auth header split by that space. So at this point, if the auth type does not equal basic, then we want to return reply.status 401 because it's unauthorized .send error requires basic auth username and password. Okay, so we send, got basic auth here. If I change the authorization to be a different type of authentication, this is using JWT bearer, and type in here, you'll see the header has the word bearer instead of basic. So when I send this, it says requires basic auth username and password. So now we can start decoding that auth key. So say const credentials equals buffer.from our auth key. And I've got another argument which says what type of encoding is this string encoded with, and it's encoded with base64. And I want to convert that buffer to a string. So toString, and what encoding do I want to use for that? I want to use ASCII. And for now, I'll just console log those credentials so that we can see them. So we know we're sending username, password, password 9, and it's being sent by this string. If I send that on my server, I'm getting jamesanderson.example.com : password 9. So just by decoding the buffer, recoding the buffer, there's no encryption going on here. It's just a different way to encode characters. We're able to see what's going on. So the username and the password are being split by this colon. So I can split on that colon. And instead of credentials, I can have email and password like that. Email and password by doing array destructuring. So if I send a request again, email and password. Brill. Okay. So by this point of our middleware, we know that we have a username and a password. We know it's been sent by the authorization header and it's using basic auth. Now we want to check, does a user with that email address exist in our database, and does their password match when it's been hashed? So let's find out. So we'll use a try catch block now, because there are various things that are going to happen. And if there's an error that we're not dealing with, we'll log it out to our console, and then we'll just return to our user, reply.status 500. We'll just let them know something went wrong. An error occurred during authorization. In our try block then, I want to get to user. Const user equals await user, capital U for user, so I'll need to import my models at the top, .find one. So this will return null if the user isn't found, or will return with the user. And I want to find where the field email is email. So let's console log that user and have a look what we can see now. So we're getting James back. If we had an email that didn't have a user associated with it, so James Anderson 1, for example, then we get back null. So I want to say if I don't find a user, so if not user, we will do a return reply.status 401.send error user not found. Now it may be that you want to be more obtuse and just say username and password were incorrect so that people don't know if it's the username that's wrong and the password that's wrong, or you may want to be more helpful. So at this point in the code, we know that there's a user in the database that matches, and now we want to check does their password match. So to do that, I'm going to go back to my model and I'm going to add a new method to my model. It's a really nice way to extend and to encapsulate this logic. The model should be responsible for comparing the password. We might want to do this in several places in our code. So let's put it in here. So again, I'll do user schema dot methods. And the method I want to use is compare password. And that's going to be an async function and it's going to receive the password. I'll do a try catch. In the catch, I'll just console log the error in case something goes wrong and I will throw the error. I might want to handle that in a different way, but that's what I'm going to do here. And then what I'm going to do in here, my try block, is I'm going to await bcrypt.compare. And what I want to compare, the password that's being passed in and this .password, so the password that is contained in the database object. Now what this will do, it will look at that string that we saw in our response. It will see $B2, so this is Bcrypt, goes, yes, I know that. $10, brilliant, I need to do 10 rounds of encryption, 10 salt rounds. It'll then look at the next bit of the string and be able to decode the salt from the password. It takes that salt and the incoming password, it runs its function and compares the result to the result in the database. By having different salts for each password, it makes it more secure. So now this compare function exists. So back in my auth middleware, I'm able to say const isMatch equals await user dot compare password, and we'll pass in the password that we have got from the incoming header. We console log that for now. So console log isMatch. We'll send our request. True, it is a match. We'll change this to password 90. We'll send our request. False, it's not a match. Awesome. So the last part of the middleware is just to handle the if not is match case. So if it's not a match, we'll return reply.status 401.send error incorrect password. Okay, so we send now, correct password, everything's working fine. Incorrect password, we get that ready to go. Whoa, so we've done a lot. We got the header and confirmed we had it. We split the header and confirmed it started with basic. We then took the rest of the header, decoded it from base 64 and converted it to a string of type ASCII and split it on the colon. That gives us an array of two values. The first value would be email. The second value would be password. We then use the email to try to find a user with that email. If that user didn't exist, we're sending a 401 error. We then compared the password. If the password was incorrect, we are returning with an incorrect password. Like in my previous video with API key handling, I want to show just how I would use this for a single route. So at the moment, it's being applied to every route. So I'm going to get rid of that and go to my user.routes.js. At the top here, I'm going to import my basic auth. And for the post function, in between the route and the controller function, I'm going to add an options object, pre-handler basic auth. So now anyone can get users with or without passwords, with or without cracked passwords. But if I want to post and create a new user, I'm going to get no authorization header. So I'll go to authorization, basic auth, and we'll get James's password again. James Anderson, password 9. There's one other problem I want to fix. When I get all the users, the password field is being handed back. Now that includes the salt and the hashed password. Working backwards from that is quite challenging to be able to get the plain text password, but is theoretically possible. So I don't want to send back that password field. So let me fix that. In my model, password set to type and required to true, I'm going to add select false, which means when I request this header, the password field is not coming back for anyone. But that creates a problem because that's true for any request, even those that are trying to check the password during the authorization. So in that instance, in my auth middleware, when I request a user, I'm going to explicitly select the password. That will counteract the exclusion of the password otherwise. And now when I try to create a new user, that's going to work fine. Getting the users now, no one has their password, and our auth middleware is working. Encrypting our passwords in our database is vital for our user security and for the integrity of our system. But there are a couple of problems with this that we'll look at in future videos. First of all, when we're using HTTP, the headers and the body of our request are in plain text over the network. So if I'm sending a username and password for every request, and there's a malicious user on my Wi-Fi network who's listening to the traffic, they can get my username and password at that point. So we should use HTTPS, so Secure Hypertext Transport Protocol. So we'll look in a future video how to do that. Another problem with this is just the sending the username and password each time. There are more opportunities for someone to be able to intercept that. And so in a future video, we'll look at another approach, bearer token, and something called JSON Web Tokens or JOTs. If you find this video useful, please subscribe below. And if you comment below that you've subscribed, I'll reply to every comment that's there. I've been Kevin, do learning around the internet, and I hope I see you in the next video. Thanks now. Bye.